class 10 children, as we have begun the chapter 14 circle, and we have already discussed these 5 formulas in my previous video. So today I will add some more formulas in the list. So first of all, today I will discuss at least these 2 formulas, and the remaining other few more formulas I will be discussing in the next video. So let us learn some new formula today. Now we have a formula which we have learned in class 9 as well. The line from the center of a circle to the midpoint of a chord bisects the chord at right angle. That means, you know, AB is a chord. A line passing from one end to the other end but not passing from the center is called chord. So a line is coming from the center and it is touching the chord. So in this case what happens, this line coming from the center, please point to be noted, coming from the center, what it does, it bisects the chord equally. That means if it is suppose 6 centimeter, it will be now 3 centimeter each, 3 centimeter, 3 centimeter. And while bisecting, what happens, it makes 90 degree at both the end. So this is all about this theorem. So this theorem, please you remember, only condition is it should come from the center. Now next is a theorem or formula based on tangent. Now so you can see one tangent is there. The tangent's name is AC. What is tangent? Actually, if a line just touches the boundary or the circumference of a circle and passes away, such lines are called tangent. Like you can see so many tangents here, just touching the circle and going. So like here all these lines are tangents. So these all are the formulas based on tangent. Like you can see here one tangent is here. So here the formula is the angle between tangent and the radius drawn to the point of contact is 90 degree. So now this is the point of contact. At this point tangent touches and goes. So if a line will come from the center and touch the same contact point, then it will make 90 degree. It means to say, like from here it will be 90 degree, this will be 90 degree. This line, the angle between this tangent and this line, there will be 90 degree. So that is what all about the like angle ABO, that is you can see angle ABO will be 90 degree. So one more formula today I will add, and then remaining formula in my next video I will add. So number 8 formula, from any point outside a circle just 2 tangents to the circle may be drawn and they are of equal length. That means from a particular point we can draw 2 tangent to a circle, not more than that, only 2. So from this point you can see one tangent is TA going further and one tangent is TB going further. So only 2 tangents can be drawn and both of them will be equal. That means TA equal to TB. So that is what all about number 8. So number 9, 10 again in the next video I will discuss, because if I will discuss all the formula at a time, it may be a problem for you to understand. So part by part I will explain. And don't forget these 5 formulas. So these 5 formulas also are important, and now today I have added 3 more. So based on these questions I will do a question for you children. So here I am going to begin question number 12. In the figure given below, O is the center. Okay, O is the center of the circle. Now tangent at A and B meet at C. See, that means here they want to say AC and BC are the 2 tangents. That means contact point is A and B and both of them have come from point C. If angle ACO, that means angle C, ACO, that means A to C, C to O, center is C, so angle ACO is 30 degree. Find BCO. Where is BCO? BCO. So you have to find this lower part. Now angle AOB means the whole part of O, the upper part, lower part, you have to add and find AOB. And third one APB. So you have to find P. APB means angle P. So now let us start. Just now I have taught one theorem to you, three formulas to you. Please, that will be used here. Now let us start. From the given figure, in this figure, there are two triangles, triangle ACO, that is upper triangle, and triangle BCO, lower triangle. So these two triangles they are speaking about. Now in this two triangle, AO equal to BO, AO equal to BO, you can see both of them are radius because O is center. So AO and OB are radius. So both of them will be equal because they are the radius of same circle. Now AC equal to BC. You can see this AC equal to BC. Just now I taught you a theorem or formula, I will say, that when from the same point two tangents can be drawn and both of them will be equal. Just now I said is same thing. So we can say AC equal to BC because they are the tangent from the same point. So on that case, tangent from the same point, yes. And now OC is common in both. OC you will find in upper triangle as well as in the lower triangle. So OC equal to OC is common. So when the three sides of a triangle are equal, it is said the triangle will be concurrent. Triangle ACO will be concurrent to triangle BCO. And when the two triangles are concurrent, that means all the angles will be equal to each other. That means if it is 30 degree, the lower part also will be 30 degree. That is all about concurrent triangle. So that way we can prove that triangle ACO is equal to triangle BCO, that means lower part, because concurrent, and both of them will be 30 degree. So this was our first question, find BCO. So BCO is 30 degree. So this is our answer. Number 2, you have to find AOB. So you have to find this throughout the portion of O. So first what they have done, triangle CAO, that means angle A will be 90 degree. Now and angle AOC will be equal to angle BOC. One very important thing I want to say you children. Now why angle CAO is 90 degree? Just now I taught you, whenever any line comes from the center and touches the contact point of a tangent, then it makes 90 degree. We have learned. So you can see here A is the contact point and OA is the line coming from the center. So that means here it will be 90 degree. Just now which I taught, formula number 7. Based on that we can say that angle CAO will be 90 degree. And one more thing we can say, angle AOC will be equal to angle BOC because both the triangles are congruent, and when they are congruent, if whatever will be this O, the lower part of O will be also same. Now based on that we can say 180 minus 90 plus 30 because the upper part is 90, lower part is 30. So when two angles are known, third angle we can find by adding these two values with and subtracting with 180. So 180 minus the two known values. 90 plus 30 is 120. 180 minus 120 is 60 degree. So we can say this is 60 degree, then lower part also is 60 degree because they are congruent triangles. So that's why angle AOC equal to angle BOC and both of them are angle 60. Now if it is 60 and lower part also 60, then the throughout the portion will be 60 plus 60. So we can say now angle AOB will be 60 plus 60 or double of 60, that is 120. So now 120 is known. Next, number 3 is angle APB. Very important children. It is said angle at the center is double the angle at the circumference. That means whatever will be here, the center will be double. That means we can just speak vice versa. Whatever angle we have at the center, the angle at the circumference will be half of the center. So like if it is 40, if it is 80. So I can say when it is 80, it is 40. So just now we came to know angle at the center is 120 degree. Then it will be half of 120, that is 60 degrees. So angle APB will be half of angle AOB, and angle AOB is 120 degree, half of 120 is 60 degree. So this is the way we have found all these three angles. So children, the way we have discussed three new formulas today, please learn those formulas and please apply in your all these sums. Thank you children.